Hello children, welcome everybody to channel Sube. Today I am going to discuss question number 42 from MCQ part of 2019 Physics New Syllabus paper. A metal ball of mass 700 gram contains 1 liter of water at 27 centigrade. When a steel ball of mass 300 gram at 120 centigrade is dropped into the water in the bowl, the final temperature of water is measured to be 30 centigrade. Specific heat capacities of steel and water are 500 joule per kilogram per Kelvin and 4200 respectively. Out of the metals given in the table, this one, what could be the metal that the ball is made of? The metal of the ball is what they ask. So aluminium, copper, lead, iron, silver. There are 5 answers given. So I have drawn a diagram to illustrate what they say in the question. So they say that there is a container. The mass of that container is 700 grams, they say. So I converted it to 700 gram. The ball is this one, ball. So the mass of this ball is 700 gram. So that means 0.7 kilogram. So first of all we have to convert grams to kilograms, you know that. Then they say contains 1 liter of water, but we have to convert it to mass. They have given the volume. What is the mass of 1 liter? We know that is 1 kilogram. That is a simple thing. Even in chemistry or in physics we use it. 1 liter is equal to 1 kilogram. So we write it like this here. So then they have given the specific heat capacity. Here specific heat capacities of steel and water are 500 and 400 respectively. So we have to take 4200 here. That is what they have given. So we denote it by S water, SW. Then they have given they say that there is a when a steel ball of mass 300 grams. So there is a steel ball whose mass is 300 grams. So we convert it to kilogram. So 0.3 kilogram. So this is the mass of this ball. So we denote it by MB for ball. MB. Then the temperature has been given 120 of that ball. So we have written it. And then 500 specific heat also. We denote it by S ball, small b here, 500. So that is the summary of the question. So this method is called method of mixing. That means we mix this ball with this water. So this is the first step before the final one. Finally they say what happens, the final temperature of water is measured to be 30 centigrade. Final temperature of water after dropping this ball, the final temperature is 30 centigrade according to the question. So let us draw that part also. So I have drawn the diagram to illustrate what we can see after mixing the ball, iron ball, to this water in the container. So this is how we can see it. So the temperature they have given, final temperature as 30 centigrade degrees. So that means the temperature of this water is finally at 30, and this iron steel ball also at 30, and this container also at 30. Final temperature is that. we don't have to separate them because all these three are at equilibrium state. Therefore, we can take the final temperature as 30 centigrade degrees of this each. So these types of question we call mixing method. How do we solve these types of questions? We use conservation of energy. That means heat gave equals to heat absorbed. So first of all, we have to identify who give heat away, who emits heat, who give heats away. So that we can decide by looking at the initial temperature. So this one is 120, this one 27. So heat flows from the higher temperature to the lower temperature. Therefore, this steel ball is the one who gives heat. Then this water is the one who absorbs heat. So therefore, we have to write, we write ms theta equation, ms theta minus ms theta 1, that is the amount of heat. Therefore, we have to write now those equations. So I said you have to first of all identify who gives heat and who absorbs heat. So according to that temperatures, we can write here the steel ball gives heat equals to who absorbs water and the container absorbs heat, but they don't have mentioned that no heat loss is there, because they haven't used a calorimeter even, and they just say a container, a bowl is used. So that means heat must have gone to the atmosphere. When we mix it to here, and even after mixing, what happens? Heat flows to the atmosphere. So that we have to take into account. That is the heart of this problem, I see, and you should guess that also, because they haven't mentioned that heat loss is negligible. They haven't said that. Therefore, we have to take the heat taken by the atmosphere. Let us say that as Q. Let us assume that as Q. What is Q? The heat absorbed by the atmosphere, the surrounding. So heat absorbed by the surrounding, we have to write here Q, atmosphere by atmosphere. So this is the equation now we have to use. If there's no heat lost, this one we don't have to write, but here there's a heat lost. So we write ms theta 2 minus theta 1 term to all these. So without writing the symbols, let us substitute directly the values. So the mass of the steel ball is 0.3, specific heat capacity 500. What is the temperature and change? 120 to 30. The ball is now at 30. So how many degrees? 90. So we can write M is 0.3, S is 500, temperature change 90. So regarding water, M is 1 kilogram, because they have given it as 1 liter. We know the mass of a liter is 1 kilogram, so we can write it 1 times 4200. They have given the specific heat capacity. How many degrees changed from 27 to 30? 3 centigrade degrees we have to write here. So plus, then container, ms theta 0.7, S we don't know, that is what we have to find here. Out of the metals given in the table, what could be the metal that the ball is made of? So we have to select by looking at these values. So values are specific heat capacity, they have given. So therefore we have to find out first the value for this specific this particular in this particular experiment, what is the metal they have used. So the specific heat capacity of that metal we have to find out numerically. Then we have to select from this to this way. So therefore we have to take it as say that is S just specific heat capacity of this container is L. I don't use this word because it will confuse with this B steel ball. I say container. So here now we are going to write the term for the container. Mass 0.7, S we don't know, temperature change same as this 3, because water and the container cools not cools, heat up simultaneously, heat up simultaneously. Therefore we write this 3 same temperature. So plus this Q we don't know. So now here I have to simplify this. So since there's 3 in most terms, I divide right side by 3 and left side by 3. So 3 to 3 cancel, here also cancel, here 0.3 there are 10 times to 3, then this 0 cancel with this 0. So we have 500 times 9, 4,200 only, plus 0.7 S plus Q divided by 3. So here we have to multiply 0, 0, 9 times 5, 45. So we have to take this 4,200 and subtract from this one, then we get 300 equals 0.7 S plus Q divided by 2. So now we have to simplify this using a special method. That means we don't know Q, we don't know S. So therefore we can't just simplify this the way normally we do. So let us assume that Q divided by 2, the heat absorbed by the surrounding atmosphere, divided by 3, here divided by 3. So let's assume this one for a moment 0. Just for a moment let's assume that this term is 0. Then we don't have to write it. Later we can consider it after finding the value for these two terms. Then 3000 divided by 7, we get 4 times, then 20, 2 times, then 8. So as a whole number, 428 is the exact value if no heat is lost to the surrounding. But really what has happened, this term is not 0. So assume this term is something like 100. I use numerical values because then you can understand easily. So then how we have to use, how we have to simplify. Then 300, we have to first take this one to this side before we divide. Then 300 minus 100 equals 0.7 S. Then 200 we get divided by 0.7. That means 2000 divided by 7. Then 2 times, 8 times, then 5. That is the value for S in practical, in real experiment. So we can't say exactly this one, but somehow S must be smaller than 428 or less than 428. Why? We assumed this one as 0. but actually it is not 0. It has a certain value. So if we applied that, substitute that real value, we get something like this. However, it is smaller than, less than 428, smaller than this value. So therefore, we can't say exactly this one, but we can say the real value is smaller, less than 428. Therefore, we have to select, choose a value who is below that. So 450 is there, not that. We have to take the value below 428. So 428 is this one, nobody else. So therefore, the metal must be copper. So this one is the correct answer. We have to choose the metal, that must be copper. So children, the answer is 2. The second one, I think you understand this problem, how I solved it. Very simple, but there is a small trick here. You have to do it. So therefore, some people might not get the final answer. Everybody can come to this level, but after this they might throw the problem, throw the question, and just select some answer randomly. So that is the thing that happened. So you have to learn these types of tricks. So children, thank you very much for watching my videos. If you are happy, please subscribe my channel before you leave. So see you tomorrow at 8 o'clock p.m. Then see you. Goodbye.